Hello. In this video, let us look at what happens if we have two equations, two straight lines in two dimensions. So two lines in 2D. There is only four possibilities that could happen. So the first one is, let's say I have an equation y equals 3/2 x plus 1, and the second equation is negative x plus 2. Now, we already know how to sketch these, so let us make a sketch and see what they would look like. So the first equation has the y-intercept, which is the b, as 1. So we count 1 up. And then from here we use the rise over run to get the second point. So 3 units up, 1, 2, 3 units up, 2 units to the right. That's the second point. If I connect them, that's my straight line. The second straight line starts at 2, 1, 2, and then has a slope of -1 over 1. So 1 unit down, 1 unit to the right, and they cross. They cross in there is nothing particular about how they cross. There is no unique angle where there is no special angle where they cross. They simply intersected. So to notice what's unique about this situation. So what's particular? So the slopes from the two equations would have to be different. So slope is the number in front. So the slope from line 1, this is the slope from line 1, is not the same as the slope from line 2. That must be true. And then the lines simply cross. They cross in no particular way. So that's choice number 1. That's the first possibility. The second possibility is we could have lines that do not cross at all. So such lines are called parallel. So here is my coordinate axis. Let's undo this. So here is my y, my x, and the two lines that are parallel. So let's say the first one is y equals 3/2 x plus 1, the same one we already had. So 1 unit up, 1, 2, 3 up, 2 to the right. First one. And then the second line would be, that's y1, and then the y2 would be 3/2 x minus 2. So this one starts at -2, -1, -2, but has the same slopes. 3 units up, 1, 2, 3 units up, 2 to the right, and so up, 1, 2, 3 up, 2 to the right, so it looks something like this. And these lines would be parallel, and they would be parallel because they have the same tilt. So the tilt of the first and the tilt of the second is the same. And the tilt is measured by the slope, and we notice that the slope numbers are the same, so for both of these lines. And it's not coming out to be parallel, but that happens. That's why we call it a sketch, and it's not precise. So that's a second possibility. Third possibility is the lines could actually cross in a very particular way. They could be perpendicular. So if the two lines cross at 90 degrees, so let's say here is our first, the same one we had, y is 3/2 x plus 1, and the second one would be -3/2, y is -2/3, -2/3 x plus 2. So this one starts at 2 units up, that was 1, 2 units up, and then it goes 2 down and 3 to the right. So 2 down is back to the origin, 3 to the right, 1, 2, 3, somewhere here. That's again a loose sketch, but the two lines would be perpendicular. We draw a little bracket to show that the lines are perpendicular. So here is the line, and this little bracket tells me that it's 90 degrees. Now, the thing to notice about the slopes here is that the slopes are opposite signs and the numbers are flipped. So the original is 3/2 and then the other one is -2/3. So that means the slopes, so for the lines that are perpendicular, perpendicular looks like the symbol for it is upside down T. That's a perpendicular symbol. And for the perpendicular, the slope of the first is negative reciprocal of the second. So negative reciprocal. Basically, the signs are opposite and the numbers are flipped. And for the symbol for the parallel is two lines, like two capital I's, which kind of looks like they're parallel. And that's exactly the symbol. So in homework or in the quizzes, sometimes we'll see these symbols as opposed to the question being spelled out. So you can say, is y1 parallel to y2? Is y1 perpendicular to y2? Or neither. So that's the first. We saw the three possibilities. There is one last possibility that could happen. And that last possibility is we could have the same equation given to us twice. So let's say the first one is the same one we dealt with before, 3/2 x plus 1. And the second equation is 2y is 3x plus 2. Now, we notice that the second equation is nothing more than double of the first. The second equation does not contain any extra information than the first one does. So this is just two lines which are really the same line twice. So if we were to sketch it on a notepad, we would see the first line going through just like it did, and then the second line will retrace exactly the same points, point for point, and you'll simply see one straight line as opposed to two. So these are the four possibilities that we will encounter if we have two straight lines. So here is the possibilities, and they are: the lines could simply cross, they could be perpendicular, they can cross at 90 degrees, they could never cross, they are parallel if they don't cross, or it could be the same line twice. Now, if it's the same line twice, then of course we would notice that the slope from the first is the same as slope from the second, and the y-intersect of the first is the same as y-intersect for the second, because it is the same equation twice. Whereas for the perpendicular, it doesn't matter what the b is, as long as the slope of the first is negative reciprocal of the second, the lines would be perpendicular. And for the parallel, as long as the slope from the first is equal to the slope of a second, the lines would be parallel. Assuming, of course, that b1 is not b2, because if they are the same, then it's the same exact equation. But if they're different, b1 is different from b2, there is space between these two parallel lines, and they really are then parallel. And that's it. In the next video, let us look at how to tell the if the two equations represent parallel lines, perpendicular, or neither. So we will start with a system of equations, two equations, and we'll look at the coefficients and see and the slopes and see if the equations represent parallel, perpendicular lines or neither. Thanks a lot for your time. Take care.